Hello everyone, welcome to Mechanical Sati. This is the sixth lecture on thermodynamics. So as you know, we are discussing some probable or important questions for GET and IFET as well. And as I have said already here before this, that these questions which we are considering over here, so this will be helpful for also other exams where numerical types questions is being asked. So here we are taking questions from past law of thermodynamics, heat interaction, work interaction, and energy interactions as well. So we are giving some importance on these topics because a maximum numbers of questions is being asked from these chapters basically. So in this video also we are going to solve another important question. So without wasting time, let us move forward and start our discussion on it. So for today, this is the question. So let us first try to read it. So here it is telling that 3 kg of air in a rigid container changes its state from 5 bar to 15 bar while it is being stirred. Okay, and at state 1, that is at state point 1, temperature is also given as 60 degrees centigrade. Okay, and the heat absorbed is 200 kilojoule. So during this process, that is when stirring is taking place, when it is being stirred, at that time also heat is being absorbed by the system, that is given as 200 kilojoule. We can assume that air is an ideal gas, and with a constant specific heat is given at constant volume, that is given as 0.714 kilojoule per kg Kelvin. Okay, and we need to find out the final temperature. That means the temperature at state point 2 and the change in internal energy, that will be equal to E2 minus E1 basically, and the work done. So any competitive exam or any job oriented exam, you'll be finding only one question from all these three. So we have generalized this question. So we are taking all these probable questions. So three questions we have taken over here to calculate the final temperature, to calculate the change in internal energy, as well as to calculate the work done. Okay, so let us try to solve it. So before solving, I will suggest you to solve by yourself, and after solving, try to compare your solution with this. Okay, so let me solve this. So for solving any thermodynamics questions, so we should first draw the process diagram. So let us try to draw the process diagram over here. So here we can draw the pressure versus volume diagram. Why, I will tell you later. So pressure in both the state points we know the pressure. So at state point 1 pressure is given as 5 bar, and at state point 2 pressure is given as 15 bar. Okay, so let us try to draw the process diagram. In y axis I will be taking pressure, and in x axis I will be taking the volume. Okay, so pressure I may take in terms of bar as it is given in the question. So pressure in terms of bar, okay, and volume in terms of meter cube I can take. Okay, so if we read the question carefully, first of all it is telling that it is a rigid container. Okay, so what does it mean? So a rigid container means actually whatever gas may be inside that container, that doesn't change its volume. Okay, so the volume of air is not going to change over here. So throughout the process which is being carried out in that system, that will be our volume will be constant. So we can assume that this is a constant volume process or isochoric process actually. So if we have to draw any isochoric process under the PV diagram, then that will be a constant, that is constant line, continuous line, uniform line, and that will be a vertical line. So let us try to draw that vertical line over here. So let me use another ink. So let me use red one. So we can get a process somewhat like this. So here our state point 1, where pressure will be 5 bar, and here this will be your start point 2 where pressure will be 15 bar. So to show that, let me use another ink. Okay, so this will be somewhat here, which will be constant pressure, sorry, at 15 bar, and here will be having a pressure that is 5 bar. So this will be correspond to 5 bar pressure. Okay, and this will be correspond to 15 bar pressure. So this much data is given to us under the PP diagram. We can look at. Okay, so we will be trying to write all these data over here. So m is given as 3 kg. Okay, then p1 pressure at set point 1 is given as 5 bar, and temperature is given as 60 degree centigrade. So we will be trying to convert that into absolute scale. We have to add 273 with it, so it will be converted into 333 Kelvin. Okay, and P2 it is given as 15 bar, and net heat interaction. So during that process, heat interaction, that is Q1 to 2, it is given as 200 kilojoule. Okay, and the Cp value it is given as 0.714 kilojoule per Kelvin. So first we can calculate the final temperature, because we have assumed that this is an ideal gas. So ideal gas equations can be applicable over here. So it will be using the ideal gas equation in both these tests. So I can write this equation. So let me write it over here. That is P1 V1 divided by T1. That will be equal to P2 V2 by T2. Okay, so as we can see, this is given as this is a rigid container. That means volume is not going to change. So we can write that V1, that is volume at set point 1, will be equal to volume at set point 2. So that we can show over here also. So here we can tell that volume is not going to change. So V1 will be equal to V2. So they can be cancelled with each other. So next, we want to calculate the value of T2. So let us try to calculate that. So T2 can be calculated as P2 by P1 into T1. So P2 is given as 15 bar, and P1 is given as 5 bar, and T1 it is given as 333 Kelvin. Okay, so simply it will be calculating this, then we can calculate the value of T2 as 999 Kelvin. So this may be the answer for this question, that the final temperature of the gas as 999 Kelvin. Okay, so this was as simple as this. Okay, so let us next try to calculate the value of our change in internal energy. So this is an ideal gas, it is being told here, and as this is a constant volume process, so we can assume that this is a quasi-static process actually. So for a quasi-static process of an ideal gas, we can write down the change in internal energy as follows. So du we can write like this, that is m into Cv into dt, where dt is the change in temperature. So that I can write as T2 minus T1. So that will be equal to m Cp into T2 minus T1. So here all the data are known to us. So simply let us put all these values over here. So m is given as 3 kg. So 3 into Cp is given as 0.714 kilojoule per kg Kelvin. Okay, and T2 we calculate we calculated it now, that is 999 Kelvin, and T1 which was given previously, that is 333 Kelvin. So it will be calculating this value. So we are supposed to find, that is 1426.57, and it will be in terms of kilojoule. So this will be the answer for second part of the question, that is change in internal energy. Okay. So now let us move towards third part of the question, that is net work done. Okay. So we need to find out the work done during that process, that is the constant volume process. So some of the students may make mistake over here, that by saying that this is a constant volume process, so they may assume that there will be no work done, and there will be no work done, so they may put the answer as 0 over here. So that is the common mistake done by most of the students. So here we can say the expansion work is 0 due to constant volume process, and this is a quasi-static process and ideal gas. So expansion work may be 0, but there will be another term, another type of work is involved here, that is stat work. So stat work cannot be 0 over here. So we have to find out the stat work, and that will be the work done for this process. So let us try to put, sorry, so let me use another page over here. Okay, so according to first law of thermodynamics, so first law of TD, we know that heat interaction, that is from 1 to 2 process, that will be equal to change in internal energy plus work interaction during 1 to 2 process. And we need to find out the work interaction, that is work done, that is from 1 to 2, and that will be equal to Q12 minus dE. So everything is known to us, so simply we have to put all these values over here, and here if we will see, then heat interaction is given, that heat is being absorbed by the system, so that is given as 200 kilojoule, and we have already calculated the change in internal energy. So let us put all these values and calculate this one. So here heat is absorbed by the system, so we can take this value as positive value. So let us put that. Okay, so I can put it over here, that will be equal to, sorry, let me use pen. So that is 200 in terms of kilojoule minus dE, already we have calculated that value, that is minus 1426.57 kilojoule. Okay, so if we will be calculating this value, then we can get as W12 as minus 1226.57, that will be in terms of kilojoule again. So this will be the answer for the work interaction or work done actually. So it will be seeing that here we are getting work as a negative value. So negative value, it is showing that work is on the system over here, because we are assuming in thermodynamics that work is on the system will be always negative. So this is one of our assumptions, and as here standard arc is given to the system, so that will be work will be obtained as negative. So this will be the answer for this question. So if you like these videos, then press on the like button which is given below, and if you are new here, do subscribe it and share it with your friends, whoever it needs it. Okay, so thank you for watching.